Welcome back, students. Now we will study about the methods which are used for preparing alkanes from different compounds. And this is an important topic because you will find questions based on this, and it contains some name reactions like Wood's reaction, which is a very important reaction, and number of questions are asked on this equation. So study this carefully and try to solve problem based on this. Let's start with our topic. Preparation of alkanes. Now we are going to discuss some methods which are used for preparation of alkanes. Okay, and the first method which is used for preparation of alkanes is hydrogenation of unsaturated hydrocarbon. Alkane, being a saturated hydrocarbon, can be prepared from unsaturated hydrocarbons by their hydrogenation. Hydrogenation means addition of hydrogen. Okay. And this is a very common method which is used for preparing the vanaspati ghee from vegetable oils. What happens that in this method, hydrogen is added across the double bonds of alkene or alkynes in case of triple bonds, and this reaction is done in the presence of catalyst platinum, palladium or nickel to produce alkane. So alkene can be converted into alkane. Ethene is converted into ethane by hydrogenation, passing hydrogen gas in the presence of nickel. Similarly, propene can be converted into propane, and propyne can be converted into propane. Okay, if an alkene has to be converted into alkane, let's say in that case this is an alkyne which is to be converted into alkane by this method. So we have to add two molecules of hydrogen in the presence of platinum, palladium or nickel as a catalyst, which will result in the formation of again alkane. So this is called hydrogenation of unsaturated hydrocarbons. Now secondly, alkane can also be prepared from alkyl halides. Alkyl halides accept fluorides. On reduction with zinc and dilute hydrochloric acids give alkanes, just like this. This is chloromethane reacted with hydrogen in the presence of zinc to produce methane. Similarly, CH3, CH2, Cl, which is ethane, chloroethane, can be reduced in the presence of zinc and hydrochloric acid to form CH3, CH3. This is ethyl chloride. This is ethane. So this is one method for preparation of alkanes from alkyl halides. Now the next is Wood's reaction. This is a name reaction. It is an important reaction in which alkyl halides on treatment with sodium metal in dry ether, that means ether which is free from moisture, give higher alkanes. So this is an important method which is used, and in general its reaction can be represented in this way. What happens? Let's say it is an alkyl halide. This is another alkyl halide. Two molecules of alkyl halide may be similar also. When it is reacted with sodium, two sodium metals, sodium halides comes out along with an alkane of higher molecular mass, to molecule of NaX. This is a general representation for Wood's reaction, and Wood's reaction is used for preparation of higher alkanes, as we can see, containing even number of carbon atoms. And there are the examples. Bromoethane, when reacted with sodium metal, these sodium bromide comes out, two molecules of sodium bromide, and results in the formation of ethane. Similarly, when bromoethane is reacted with sodium metal, this portion comes out in the form of two molecules of sodium bromide, and we get an butane. So these were the two methods which were used for preparation of alkanes from alkyl halides. First was hydrogenation, and the second one is this is Wood's reaction. The next one is Crowley-House synthesis. This is another AIM reaction, and in this what is done, that alkyl halide is first reacted with lithium metal in the presence of, yes, dry ether, ether free from moisture, which results in the formation of alkyl lithium, and lithium halides comes out. Then two molecules of this alkyl lithium, this is actually alkyl lithium, two molecules react with copper iodide to form R2CuLi, and lithium iodide is formed. Now this R2CuLi, alkyl cuprous lithium, reacts with R dash X to form another alkyl halide, to form alkyl halide, copper plus lithium halide. So in one step, this was the actually mechanism. In one step we can write it in this form also: lithium halide, alkyl halide reacting with another molecule of alkyl halide, a different alkyl halide with different alkyl group, in the presence of lithium cuprous iodide dry ether to form R dash R. This is called Crowley-House synthesis, which takes place in 3 steps. Okay. Now, preparation of alkanes from carboxylic acids. This is known as one of the methods which is used for preparation of alkanes from carboxylic acid is known as decarboxylation, and decarboxylation refers to removal of carbon dioxide molecules from carboxylic acid groups. And saturated monohydric acid salts of sodium or potassium on dry distillation with soda lime gives alkane. Okay, so this simply represents when let's say this is a sodium salt of carboxylic acid CH3COONA. This is, yes, sodium ethanoate. When this is reacted with soda lime, now soda lime is mixture of NaOH and calcium oxide. This is soda lime. It is heated with soda lime. We get CH4 Na2CO3. So this is a method known as decarboxylation. Now another method for preparation of alkanes is from Grignard reagent, and we know that what are Grignard reagents? Grignard reagents are actually alkyl magnesium halides. General representation is this, RMgX. This is Grignard reagent. So Grignard reagent on double decomposition with water or with a compound having active hydrogen. Active hydrogen means hydrogen which is attached to oxygen, nitrogen, fluorine or triple bond atoms. They give alkane like this. This is magnesium. This is Grignard reagent. When it is reacting with water, what happens that this portion comes here and this alkyl group goes with this hydrogen and results in the formation of an alkane. Similar can be done when it is reacted with amine also. Nitrogen comes, this group comes at this place and this goes with hydrogen. So we can take an example. Let's say we are reacting CH3MgCl with water, so it will result in the formation of, yes, CH3H, or we can write simply CH4 along with MgOHCl. So whenever Grignard reagent is reacted with water or any other compound containing active hydrogen, now active hydrogen is a hydrogen which is attached to fluorine, oxygen, nitrogen or triple bond, that means acidic hydrogen which can be replaced easily, it will result in the formation of alkane. Next is from preparation of alkanes from aldehydes and ketones, and it is known as Clemenson reaction. It is an important name reaction again. Carbonyl compounds is heated with excess of amalgamate, zinc and hydrochloric acid. Amalgam, we know amalgam is alloy of, yes, mercury. So a zinc which is treated with mercury and hydrochloric acid, when they react with carbonyl compound, they reduce actually the aldehyde and ketone to form alkanes, and this reaction takes place on the surface of zinc. This is the reaction overall. Carbonyl compound reacting with zinc treated with amalgam, mercury, in the presence of acid, result in the formation of alkane. So these are the different reactions in which this compound, actually this oxygen gets removed and it is replaced by two hydrogens. So this is, actually we can write it in this way also. Here we can write it in this way, two hydrogens come at the place of double bonded oxygen atom. Similarly it is this. So this is a way of reduction of carbonyl compounds to form alkanes. Next is Wolff-Kishner reaction. In this, ketones or aldehyde is converted to its hydrazone, and which is reacted with strong base to produce alkanes. Now this is a general reaction example of this. This is the carbonyl compound and it is reacting with this compound to form hydrazone. This compound is known as hydrazone, and this hydrazone is reacted with aqueous KOH to form this. Now let's have a look at the process of formation of hydrazone. Actually what happens that, let's say this is a general carbonyl compound. This is the next reagent which is being, these are the two reactants of this compound. Okay. What happens in this, that this attacks at this carbonyl carbon and this goes at this position, and this results in the formation of a compound like this. And here with a positive charge, NH2, here is an hydrogen, another hydrogen. In next step, what happens that this hydrogens comes at this position to form RCH. This becomes OH and this as NH2. Now again it has a lone pair of electrons. So in next step what happens, that this hydrogen, this comes at this place, this OH and this hydrogen comes out in the form of water molecule, and the product which is formed is RCH double bond NH2, and this is called hydrazone. This hydrazone is then treated with strong base like KOH to form aldehyde. This portion goes out and results in the formation of alkene. This hydrazone is reacted with KOH or NaOH, a strong base, to form alkanes. Okay, and this is an outline of the mechanism. This is the carbonyl group which is converted into hydrazone, which is when reacted with KOH, NO2, N2 comes out and results in the formation of hydrocarbon. Next method for the formation of alkanes is from red phosphorus and HI. By reduction of alcohols, aldehyde, ketones or fatty acids or their derivatives, alkanes can be formed, and for this reduction we use red phosphorus along with HI. This is the reagent which is used for reduction of alcohols, aldehyde, ketones or fatty acids or their derivatives. Like this, these are some examples. Here primary alcohol reacts with red phosphorus and HI, at 200 degrees Celsius to form alkane. Similarly, aldehyde can also be reduced to corresponding alkane. Ketone can also be reduced to corresponding alkane. Similarly, reduction of carboxylic acids also take place at 200 degrees Celsius. At a similar condition, anhydrides, acid chlorides, acid amides, these all react with red phosphorus and hydrogen iodide at 200 degrees Celsius, and they get reduced into corresponding alkanes. So, reduction of alcohols, aldehyde, ketones or their fatty acid derivatives in the presence of red phosphorus and HI is another method for preparation of alkanes. Now, alkanes which are formed by decarboxylation process always contain one carbon atom less than the original acid. This yield is good in case of lower members, but it is poor in case of higher member. We have just studied about decarboxylation method. These all were decarboxylation method. Now, coal-based electrolysis method is one of the another method which is used for preparation of alkanes. And in this, what happens, that an aqueous solution of sodium or potassium salts of carboxylic acids on electrolysis give alkane containing even number of carbon atoms, and this process is known as coal-based electrolysis method. You can see here is a compound sodium acetate. When it is electrolyzed in water, it results in the formation of ethane, removal of water, removal of carbon dioxide, hydrogen and NaOH. So this is another method which is known as coal-based electrolysis method, and in this alkanes are formed by electrolysis of sodium salts of carboxylic acid. Isopropyl bromide undergo Wood's reaction to form this anhexane, 2,3-dimethylbutane, propane or neohexane. So let's draw the structure of isopropyl bromide. It is something like CH3, CH3, Br. When this compound would be reacted with sodium in the presence of dry ether, this will result in the formation of CH3, CH3, again CH3, CH3H, and this compound is obviously the longest chain is this, and it would be named as 2,3-dimethylbutane. So the correct option is B, 2,3-dimethylbutane. Next question is, alkanes can be prepared from Grignard reagent by reacting with. Now recall, I just told you that a Grignard reagent, when reacted with a compound containing active hydrogen. Active hydrogen means a compound in which hydrogen is attached to oxygen, fluorine, nitrogen or a triple bond. So all these are active hydrogens. So, and when Grignard reagent is reacted with a compound containing active hydrogen, it results in the formation of alkanes. So if you know, in alkanes, hydrogen is attached to oxygen, that means it is an active hydrogen. In primary amines, hydrogen is attached to nitrogen, which is again an active hydrogen. In alkynes, hydrogen is attached to carbon. That means all these three are active hydrogens, and when Grignard reagent would be reacted with any of these three, it will result in the formation of an alkane. So the correct option is all of them. Students, in case you have any doubt in this topic, you can post that question in our discussion board. For that, all you need to do is to go to the home page of Ask IITians. There you will find an option of discussion board. You have to click there. Then in the right side, you will find a portion of Ask experts. In that, just select the category in which you want to post your question. Let's say it's physical chemistry. Then post your question here, and then if you want to attach any image, use this option to attach the image, and finally post it by clicking on get answer, and you will be answered within 24 to 48 hours by our experts. So now you know what are the various methods used for preparation of alkanes. How can we convert aldehyde, ketones, carboxylic acids, alcohols and many other compounds into alkanes? What are the methods used for this? In this you find some very important topics like Kolbe's reaction, Kolbe's electrolysis method, Wood's reaction. You should study them carefully as these are important for exam point. In next video, we are going to discuss about chemical properties of alkanes. Stay tuned.